So here we go, guys. We're now going to talk about, we've learned about recursive equations, right? The a sub 0 equals a sub n equals a sub n minus 1, right? Our start, growth. We've also learned about explicit, how to use information to, y equals, for arithmetic, a plus bx, or for geometric, a times b to the x. Okay, now we're going to kind of use them. First of all, use them to, can we make a pattern out of this? Okay, and then can we go from recursive to explicit and back? So if I give you one, can you find the other? Okay, so that's kind of the idea here. Now remember, for explicit, the a is our start. We often call it our y-intercept once we start getting to explicit. Our b is our growth, okay, often called the slope, rate of change, growth factor, all that stuff, okay? All right, so these first ones, given the recursive formula, find the first 5 terms, okay? So kind of 2 ways we can do it. We can do it like a sequence, or we could do it like a table. Let's say if we were doing it like a table, okay, I'd have my input and my output. So a sub 0, so my 0 term is negative 22. Then my first term, I'd subtract 7 from that, right? So I'd be subtracting 7 to that. And I need to get to my 5th term, right? Because it says first 5 terms, which you could argue the 0 term is included in that. You could argue that it isn't, so we'll just take a look at it this way, okay? All right, so subtracting 7 would be negative 29. Then 7 more would be negative 36, then negative 43, negative 50, negative 57. Okay? So that's just kind of the idea that we're going after there. Just making sure we can look at this and recognize the pieces, okay? Just another way to see it. So if I was just doing a sequence, I wouldn't use a sub 4, would I? Or a sub 0. I would just go, we start at 4, but my first term we subtract 8, so I'd start at negative 4. Then we would go to negative 12, negative 20, negative 28, negative 36, and so on. And there's my first 5 terms. So it kind of determines, depends on how you want to do it. Okay. In this case, we're now multiplying by 5, but same idea, right? If I did the table and an a sub n, 0 term, which would be negative 4. Then my first term timesing by 5, so negative 20. My second term timesing by 5, negative 100. Third, negative 500. Fourth, negative 2500. And fifth should be negative 125,000. Or 12,500, that's what I was going for. Okay. Again, if I just want to do it sequence-wise, I don't care which version you use. I'd say I started at 1, but I'm timesing by 6, so my first term was 6, then 36, then what's 36 times 6? 216, third term, times 6, 1,296, and finally 7,776. And there's my first 5 terms. All right, so that's if we're dealing with the recursive formula. Now, what if we're dealing with an explicit? Okay, so looking at 5 through 8. Same idea. I can start out by making a table, and if I really wanted to, I could even make a table, like this. So we've got. Let's actually do a table for number 6. So I'd have x and y, right? Whereas if I'm doing the sequence, then I would say my starting is 18, and then I'm adding 10 each time, right? I know that's my growth because it's with the variable. So it actually, my first term would be 28, then 38, then 48, 58, 68, and so on. Okay. Same if I'm doing a sequence for my exponential here. We start at 2. That's my 0 term, so my first term would be 2 times negative 6, which is negative 12. Man, why am I timesing by such big numbers? Right? Now, negative 12 times negative 6 would be a positive 72. Positive 72 times a negative 6, negative 432. Negative 432 times negative 6, positive 2,592. And then times by negative 6 one more time, and we get a negative 15,552, and so on. But if I'm doing a table here, okay, I can include my 0 term as long as I go to the 5th term. So my 0 would be negative 14, and then I'm adding 4 each time. So negative 10, negative 6, negative 2, positive 2, and then a positive 6, and so on. If I'm doing my exponential here, same idea, x for input, f of x for output on this one. My 0 term would be 2, and then we're timesing by 3 each time. So 6, 18, 18 times 3 I believe is 64. Nope, 54. Times that by 3, 162, times that by 3, and we get 486. Okay? So just kind of reviewing some of those concepts. Now let's talk about switching equations. So now we're going from recursive to explicit. So remember recursive, we've got our 0 term, okay, then our start number. To get the next output, we take the previous output and we apply the growth, whether it's add, subtract, multiply, or divide, right? So for our explicit, I like to use the y equals our start, and then add, subtract our growth times our variable, or multiply or divide our growth to the x power, right? Because repeated addition and subtraction, the shortcut's multiplication. Repeated multiplication and division, the shortcut's a power, okay? So basically, I'm just figuring out these and then applying them. So pretty easy, right? So y equals our start of negative 2. What am I doing to it? Subtract a 9. How many times? I don't know, so I put my variable times. Okay, 28, we start at negative 28, so y equals negative 28. What are we doing to it? Adding 10 multiple times. Number 11, start at 20. What are we doing to it? Subtracting 4 multiple times. Number 12, start at 16. What are we doing to it? Subtracting 3 multiple times. Okay, pretty simple, right? Where do we start? 40. What am I doing? Subtracting 4 multiple times. Now 14, you say, oh, I start at 10, but do I? That's a sub 1. And if we think about the table, a sub 1 is right here, not a sub 0. Okay? So for it to be a sub 1 being 10, we need to drop back to 6, don't we? Because we're adding 4 each time. So I'd actually go y equals 6 plus 4 times x. Now there is a way you could use that 10, and you'd have to write your equation like this: 10 plus 4 times x minus 1. Because you'd have to take into account that you're dropping back 1 each time. Kind of like that n minus 1 idea. So you got to pay attention to that. I would prefer to do it this way because I think it's easier, and I'd rather take a step back here than have to worry about forever using my equation to take a step back. All right? So let's take a look now at the geometric version. Okay, again, we started out the same way. So y equals, we start at negative 2. What am I doing? Timesing by a negative 5 to the x power. Okay, notice the difference. Subtraction and addition times by x. Multiplication to the power. Okay, that's a big difference. If you wrote it like this, that's wrong. Same way as if you'd written this one like, that's also wrong. Doesn't work that way. Okay, 16. Start at negative 3, so y equals negative 3. Timesing by 3, so times 3 to the x. 17. start at 1, so y equals 1 times 6 to the x. Now, 18, same idea. Start at 3 times negative 4 to the x. Okay, now let's pretend 19 were division, okay, instead of multiplication. Okay, because I think you know how to do it if it's multiplication. With division, we can do it two different ways. Well, we start out the same, okay, and I could put divide by 4 to the x, or I could go y equals 3 over 4 to the x, and these work. However, we generally don't see them that way. Instead of division, what we prefer is timesing by the reciprocal. So instead of dividing by 4, we times by 1/4, and you'd have y equals 3 times 1/4 to the x. That's typically what they prefer us to do for that one, even though I would accept either one of these. Okay? Now 20, again, we've got a sub 1, so that's technically not my start, is it? Okay, so it should be, I could write y equals 4 times 4, but because that's 1, I have to take it back to 0 in my exponent and put x minus 1. So instead, I can drop it back, right, because our first term would be 4, and have our 0 term 1, because 1 times 4 is 4, and I could go y equals 1 times 4 to the x. Okay. Now, all of these, I could write it in sequence notation, right? A sub n equals 1 times 6 to the n, and it's the same thing. So I could do that for all of these. Or, again, back here, I could do it with these guys. Same thing. Okay? So, all right. Okay, now let's move on to now, given the explicit formula, find the recursive formula. Okay? So again, we go back to here. So now we find the start here and the growth here or here, depending on which type. And we're just going to plug it in to the pieces that we have. Okay? So my start would be 25. So I'm going to go a sub 0 equals 25. Then a sub n equals a sub n minus 1. What am I doing? I'm minusing 6. And that's all I do. Now, some people try to throw that variable in there. Okay, that is not correct because I'm not subtracting 6n, I'm just subtracting 6. Okay, so you don't put the variable with it. You don't put the variable with it. But on all of these, I'm going to go a sub 0, a sub n equals a sub n minus 1, right? Because that's how we do recursive, whether it's the function or sequence notation or just our regular y and x or our function notation. We're still treating it the same, right? And we go, our start is 18, so a sub 0 equals 18. We're adding 2 each time, so plus 2. My start of 14, adding 4 each time, plus 4. Starting negative 52, adding 30, so plus 30. Okay? And I could do the a sub n equals a sub n minus 1 first either, and put the minus 8 here, and the a sub 0 would be 21. So it doesn't matter the order I put them as long as I connect the correct pieces. Okay? That's what's important, is putting those correct pieces. Okay? Now 27 is different because now we have that n minus 1. But remember, that's telling us that this is actually a sub 1. So I could just go a sub 1 equals negative 2, a sub n equals a sub n minus 1 times 2. Or I could go a sub 0 equals, and then work my way back and say negative 2 divided by 2, so negative 1 would be my a sub 0. And then include that part. Okay, that's up to you. Doesn't matter how you do it. Okay, 28, start is negative 2. My growth is timesing by negative 6. Not negative 6 to the x. Again, we don't include that variable. We just need the growth there, whether it's a constant ratio or common difference. Okay, now 29 is just times 2. Okay, so you're like, well, all I have is my next term to to get to my previous term times 2. Okay, because it's 2 to the x, which means I'm repeatedly timesing. However, my a sub 0 is actually 1, because I could rewrite that as 1 times 2 to the x, because timesing by 1 doesn't change anything. So if you don't see it, okay, you got to recognize that part. Okay, 30, a sub 0 equals negative 3. A sub n equals a sub n minus 1 times negative 3. Pretty easy when they're the same exact numbers, huh? And then I believe, yep, those are our last. So a sub 0 equals 4. A sub n equals a sub n minus 1 times 3. Okay, again, we just see the growth. So times negative 3. But like we did up here, it's really 1 times negative 3 to the n. So a sub 0 equals 1. Alright guys, there we have it.